Okay, welcome back guys. So in today's video, we will see the storage, like how the storage helps us to persist our data in the Kubernetes, right? If you have gone through to my Docker beginner series, right, which is a strong recommendation for this Kubernetes. So we have already discussed this storage, like how storage works in Docker, right? Like layer by layer, that how the Docker is storing the image and maybe the other parts, right? So same way here also like the storage where we need to store our data, right? So before we jump into like how we can attach the storage to our pods in the Kubernetes, let's understand why we need a storage, right? Let's say you have an application, right? There are two kind of application basically. STAT, stateless, and there is a stateful, right? So let me quickly summarize what all these. Maybe you guys already aware, right? You are smart enough. Stateless is something where you don't need to worry about the data, right? Like you just need the data live as soon as your application is running, right? The moment your application is down, or maybe you just delete that code, you don't care about the data, right? For an example, let's say you have that compress image application is running, right? This is running, and I have put some kind of event or maybe that kind of function lambda or something. If a request is coming to compress the image, what I'm doing is somehow I am quickly spinning up one pod inside my Kubernetes cluster, which is giving a good UI to that particular user, right? And there they're gonna upload their image, and using this image application, we are compressing the image. Once that you then that is done, user will gonna download that image, and that's done, right? The moment they uh, like uh, go away from the session, right? They close the session. What is happening is the pod is also going down, right? Pod is also deleted. So in this way, we don't care about the data, right? We are not storing any kind of the image, right? We are just getting the image, compressing it, and giving it back to the user, right? And then user gonna download, and that's it. The work is done, right? So this kind of nature, if your application is doing, so this nature calls as a stateless, right? Whereas stateful, right? Stateful is something like mostly we consider as a DB, right? So DB is the stateful thing, right? Where we are storing the data, where we are caring about the data, right? It is a very critical. We somehow we have the data to be placed in somewhere, right? That's how that it works. It is something that stateful, right? Let's say I'll give an example. Let's say you are let's take in a restaurant example, okay? If at home you have planned to visit a restaurant and have the dinner there, right? Now what you have done is it's just a very busy restaurant. So what you have done is there is an application already running for that restaurant. You logged into that application, you booked your table, you ordered your food, and that's it, right? You close the session. Now you left the home for restaurant. You reach the restaurant and you just go to the reception and you show your order ID, and everything is done, right? But have you ever wondered like what is happening behind the scene? Like with the less application, the session was there, the data is there. The session is gone, data is gone. But with the stateful, you have booked your table, right? Maybe you have paid some amount for to book the table. You have ordered food, right? You have that set of order, you have that order list as well, right? But you close your session, right? Now when you reach the reception, you show your phone or whatever, they with the ID they are able to confirm, yes, with this ID we have the booking, and this is your order, right? That then where the data come from, right? The data come from the DB, right? So DB is a nature of kind of stateful where we are storing the data, right? So that later on when we have need the data, right? When we have any requirement of data, we can go and we can query, right? If that is the case with the stateless, right? Let's say you are running your application, okay? And you have done everything, right? You close the session, or maybe let's say if you don't have storage behind that stateful application also, right? What if between that you left your home and you reached the restaurant, application was down, right? Your data was gone. Because with the stateless, data is there as long as your application is live, right? If in between your application go down and you restarted your port, the data is gone. You don't have any access to the data which is being generated or processed by your application, right? That is the way that we need a storage, right? So that was a quick introduction. Okay, so for me, storage are two types. let me clarify. Storage is a two kinds in Kubernetes perspective, right? Not from the storage perspective. One is something called a static, I would say provisioning, okay? Because we are provisioning a storage, right? And another one is something called dynamic provisioning. What are all these? Let me clarify. Static provisioning is something like which is a kind of static, right? Like if it is already there, right? You are just going and consuming that particular stuff, right? Maybe your administrator, right? Or the team who is responsible to manage your cluster, who is creating the storage and everything. What they are doing is they are just creating some file system, right? Already it is there. Being a developer, your pod is just consuming that file system, right? Here we are not doing any kind of live operation or maybe dynamic provisioning or something, right? It is something that where you have already created that stuff and you are just getting consumed that particular stuff. So that is how this is something called static provisioning, right? So what is happening is your administrator is creating a PVC, right? And within the pod, you are referring to that PVC. Which PVC? It is bind to that PV. And what are all these PV and PVC? They are nothing. They are just a fancy term in the Kubernetes. It is a persistent volume and it is a persistent volume claim. That means that you are claiming that particular PV, right? And how that is being assigned and everything we will see next and now. Whereas on the other hand, you have the dynamic provisioning, right? What is dynamic provisioning, right? Dynamic is something dynamic. Okay, now it's good. Dynamic is something like where we have something called SC, which is responsible to create your PV, and then you will gonna create the PVC, and then you will go. These are the same term, right? We have this. There is another called is storage class. S is nothing a storage class, like where you are just creating some kind of provisioner, right? You need to run a provisioner which is responsible to create your disk, right? Whatever the storage you are referring to, there quickly it will gonna spin up your PV and that PV will gonna bind your PVC. You are creating only PVC, right? Here you are creating a PV as well as PVC, and then you are doing your job with the pod. But in this case, you just need to create your provisioner and SC. You don't need to create a PV. Here, what we are doing is we are just creating a PVC. The moment the PVC is created, storage class will gonna spin up that disk and uh, as long as disk as and this PV as well, right? And then this PV is get binded to the PVC, and that's how the dynamic provisioning works. Okay. So what I will do is in today's video, we will just focus on the state provisioning, right? We'll just see what is PV, PVC, how we can bind it to that particular port, right? In the next video, we will see what is dynamic, where I will introduce a provisioner and the storage class, and then we'll see what we have in actions. Okay. So that was the quick introduction of the storage, like what is the storage, how we need the storage, and what is stateless, stateful, and in the Kubernetes, what is the static provisioning and the dynamic provisioning. All right, so let's jump to our master server. Again, we have that single master node server. It is running with one worker node, right? And we have both node are ready, right? So let's jump to our folder. I'm not sure whether. Mm, okay, I think I need to clone. Okay, 1 second. Yeah, this one. Okay, we are good. So let's clear our screen and let me know. So what I have done is I have added few more files. These 4 files are added to our repository. You can clone it, or maybe you can pull it if you have already cloned and you are following along. So let's see what we have in 27 number. So 27 for me, it looks like a simple pod definition file, right? Where we are just creating a pod as a declarative approach. I'm just giving some name to my pod. I am running one container inside that pod and that name is logger. I'm using a busybox image, and within that busybox image on the SSL, I am just doing some while loop which will just printing the date and writing that particular thing in the log test.log, and then sleeping for 5 seconds and again doing the same thing, and it will keep on running, right? Because it is an infinite loop, because we have put as a while as true, right? So what is happening is we are introducing a new property called volume mount, right? Look at the indentation, guys. Here the volume comes from at the inside of that array which we have defined for the first container, right? And this volume, right, it is at the container level. You can see indentation, right? It is at there. So what I'm saying is I am just defining a new property called here volumes under the spec section, and I'm just giving it is an array. Again, you can give any of the n number of the volume, right? I'm just creating a volume called log volume. Okay, I'm just giving to that volume a name called log volume, and this is a host path, right? There are multiple way. We will discuss that tomorrow, but as of now I'm using a host path. Host path is a special kind of type of volume which will create a local directory on the single, right? This host path will create a directory called this one under this path on whatever the node where you will gonna spin up that pod, right? On that pod it will create this directory, right? The type is I have given as a directory or create, whether it's existing or not. If it is existing, fine. If it is not, then create it, right? And then this is binding to my log volume. Same thing, we were putting that log labels, right? And then using the selectors, we are assigning that replica set or maybe the service to that particular port. So here also, I'm giving a name to my volume called log volume, and then this is a host type, host path type, where I have a path defined this, and under this, I am defining the nature of the path is directory, right? Now I am mounting that inside the container. Now you can see that with the container spec section, here I'm creating a container and here I'm creating a volume. So this volume I need to mount inside the container. That is why is the reason the indentation for volume mount you can see is at under this name array, right? So now the volume mount is again a new property in this, where I'm just saying the volume mount. This is the volume I have created. Now I am mounting this volume mount. What is the mount path? Mount path is this one. What is this one? This is something, this logs, right? What it is doing, it is mounting that particular directory, this directory inside a container, a directory called logs. Okay, and then I'm just giving a name of that my volume, like from where it will come. So what it will do is, first it will create this log volume. Under this log volume it will gonna create this directory. Now this directory doesn't know my container, right? Container doesn't know this directory whether it's exist or not. It will look for this name log volume, right? So that is why you can see that under volume mount I'm doing the mount path is log. This is the mount directory inside the container, and from where it will come, it will come from the log volume. That's it. Now this volume will take care of this log volume, like where this log volume come from. All right, so that's how that it is defined. Now let's quickly create it and we'll see what is happening. Okay, uh, I hope that okay, how come it is pod host path. Let it delete and then we'll see. Okay, let's quickly create this and we'll see what is happening now. So my pod is created now. Let's quickly list it. It's running, right? Let's clear the screen and let's get it one more time. Now what I will do is I will query that my slash log slash test dot log, I think, right? IT, and this is the name of that particular pod. Inside that pod, go and run this command logs test.log. All right, now you can see it is writing, right? Like in each, you can see the time is now, it is 12:24:32, right? So what is happening is it is 42. It is, if I just run it one more time, right? You can see that has written till 12:24:33, and now it has, you can see that we have few more entries. So it keep on writing, right? Like it is generating the data, right? Now what will happen if I delete this pod, right? Let's say if I'm deleting this pod, delete pod, pod is deleted, that means that data is gone because that was inside our container, right? But with this case, scenario is different because we are storing our data, right? We are persisting our data, right? Let me show you the definition file again. Let it delete gracefully, and then I will show you what is happening, right? You can see that data is still there, right? 12:23 and everything, right? Maybe let me copy and I will just paste here for reference, right? Now fine. Okay, it's deleted now. Let me clear my screen. Let's see. No pod, that means there is no data, right? But if you remember, that was the like the meant of storage, right? We are using it as a volume. That means that on the same node, wherever our pod was running, it is getting stored this data, right? If I'm doing this ls now, yeah, okay. See, this is a master node, right? And we are running it on worker node, right? If I doing the same thing under temp, so here you can see that it has created a pod logs. That's what we have created, right? If I just cat that pod logs, we have test.log and we have the same data, right? Which we capture in our this one. Let me just take it here. You can see that, right? It was started from this one, right? It has few more entries because when we have deleted, it was already, we have deleted somewhere after this, right? You can see 24:48. So this way you can persist your data, right? Now, let's say if you are doing it again, right? It is done now, right? So the last entry was, if I go to here is, last entry was 12:25, right? Let's get it again. Now you can see that 12:25 and now it is again capturing the data, right? So this way you will not lose your data, right? That is the benefit of this, right? But now what we are, and one more thing, there is a catch here. This host path is just for the testing, right? Because host path is just creating a local directory, right? So this direct, if let's say we have one more node in our cluster, right? So wherever this pod got landed, this directory will create it there only, right? And when you restart it, then there is no guarantee, right? Obviously, there are way which we have already discussed, but by default, this is something that it can be go to a different node, right? And probably there you will not find this and it will gonna create a new and you will get your data mismatch. So that is why host path is just for your testing purpose, maybe in development environment or maybe single node cluster if you are running, right? So that way that you can use this something called host path, right? Now what I'm doing is I am just creating this, right? So what is happening? Let's say if I just need to create some additional some particular fixed size of that particular volume, right? So for that we have something called pv.yaml. So what is pv is? Pv is nothing, it is a persistent volume. So you need to set your kind as a persistent volume. Name of your pv is local pv, right? What I am doing is under spec section I am just defining the capacity. I am saying capacity will be 1 gigabyte. Access mode, there are many access mode: read write once, read write many, like, and there is one more, read write once, read write many, and only a read write, right? So there are ways for this. Let me check, give me a second, I forgot the third one. Read write once, read write many. Yeah, there is one was read write once, read write many, and read write this one, right? Read only, read only, read write, and let me write it down here. I think I confused you. Read write many. Okay. Read write once, and there is one more is read only many. So these are the three access mode, right? We are defining here. Then I'm just doing again the host path. I'm creating again directory called mnt data, right? That will be created under this, and we will gonna create. And how we can create it, I'll show you. Okay. So let's create the PV now. It's simple. Kubectl create hyphen 28. It's created. If I just run it kubectl get PV. So I can see I have that one local PV is enabled. Capacity is this one. Access mode is RWO, which is nothing. It is just read write once, right? Retain policies retain, right? So what does that mean is retain is okay. There are three type of policy, right? Let me just give you here as well. Policies are retain, right? Then there is delete, right? That's what we have. So retain is something like it will gonna retain that volume, right? Like once you created that PV, and out of that PV, if you created a PVC, right? So what will happen is if your policy is set to retain, right? And if you are no more using that PVC, or if you are deleting that PVC, what will happen is your PV will not get deleted automatically. Your administrator has to delete this, right? That's what that you can, but it is not usable for any of other port, right? You cannot use it. Second one is delete is something like the moment you delete the PVC, at the same time your PV got deleted, right? That's what we are saying. And again, that is something. So what will happen is it will create this, right? And let me show you the 29 number file as well. Here, what we are doing is here we are creating a persistent volume claim. So you can see the kind is persistent volume claim, right? Again, it is a local PVC, that was local PV, and it is doing access mode read write once. Resources, I am just capturing the resources, this one. Request whatever the resources you are like claiming, I am just requesting a storage 500 maybe byte, right? So see, whenever you don't have storage class, right? So what Kubernetes does is the default behavior is they will bind automatically, right? Wherever you have this access mode read write once, and here you have read write once, right? That means that access mode is matching, and the size is also matching, right? Although it is a 1 gigabyte, but we are just like claiming for 500. That means it is matching, right? So it will gonna bind that, right? So let me run kubectl get PVC. As of now, nothing, right? Let's quickly create kubectl create hyphen app, and the file number is 29. It is done. Now, if I'm doing both at a time, so here you can see this is the PV, right? It is the persistent volume local PV. Capacity is this one. This one retain is policy is retain. Status is bound, whereas earlier status was available. Why? Because we have created a PVC, and due to this nature of the default behavior, it is already binded to that particular PVC, right? Now, this is the claim. Earlier it was empty, right? Now, where it is bounded? It is bounded to in the default namespace. There is a PVC called local PVC, and there it is bounded, right? Same way for the PVC, we have this bound, right? If there is no PV, right, which is matching the request, then it will set it to the pending state, right? But here what it is saying is you have that local PV from where you get the volume, and the capacity is this one, and this is the right. I will show you quickly, but let's finish our demo first, and then I will show you. Okay. Now delete the pod that which we have created. I think it's still running. Uh, pod dot host path. I think this was the name. Let's quickly, yeah, it's deleted now. And I will show you how you can inject this information, this PVC and PVCs inside the that file. Because in the previous file, we are using a volume as a host path, right? But now we don't have any volume. We are creating a PV and PVC because it's a static, right? I had to create this PV and PVC and then I can inject it to that pod, right? That's what it is. That means, right? So let it delete and I will show you. It's deleted now, right? We have something called this file. So what I'm saying is till here it is same, right? It's same. Volume mount, it is coming from this PVC storage, right? Earlier it was coming from that volume name. Now if you see this volume, right? I'm just giving a volume name this, but in this file, 27, you have this host path, right? But now am getting it from the persistent volume claim. And what is the claim name? I'm claim name is local PVC. That's what we have created here, right? Local PVC. So that is how it is mounting that particular. Now this path is same, right? Under the volume mount, I am mounting this particular stuff in this MNT logs, right? And here it is coming from this volume, but this volume is getting the disk from where? Earlier it was getting from host path from the local directory, but now it is getting from the persistent volume claim, and the claim name is local PVC. All right, so that is the difference only. So let's quickly create kubectl uh, create -f, and I'm gonna create this file. Let's get created now. Kubectl get pods. It's running. Right now, if I do the same exact command, okay, it is mnt logs now, not logs, right? Why? I will show you. Okay, host, maybe let's examine that file. Maybe I have changed the, okay, so pod name is pod PVC, not the host path. That was the first mistake. Second mistake is we were trying to access this, but now it is this one, right? So this command should be like this one, and I'm going inside this and I'm running this. Okay, now it should show some entries, right? You can see that. And where it is going to that this path, mnt logs. Not this one, sorry. We need to see the PV, right? So PV was 28. It is mnt data, right? If you go to the mnt data now, I am on node 1, right? Maybe let me just increase little bit behavior size here. Let's take it 12. Now it's good. Let's clear. I am MNT data, right? And here you can see I am getting this PVC, right? Let me show you one more thing. Tail -f. You can see data is coming live, right? 1, 2, 3, 4, 5. Maybe the next entry will come. See. So this way you can create that particular PV, right? And if you just say ls-ld mnt data. Okay, this way it is just creating a data, but it will gonna claim a particular size, right? Size of that file inside that MNT. Okay, it is not showing you, but because we are not putting that much of data, it is not showing, right? So that is, but yeah, on here we can see that, right? It is a 500 MB we are creating, but now the problem is, if you have consumed that 500 millibyte or maybe 1 gigabyte, what will happen to the data, right? You will lost your data. So that is the reason the storage class will come in picture, right? So we need to understand what is storage class and how dynamically it will increase the data. That we will try to put some more file on that, and we'll see that if it is getting increased automatically. in the next video, right? That is the reason, like it is something. Let's say if I'm deleting that PV, delete PV, and PV name is, or not say PV, PVC. It is local hyphen PVC. DELETE. Okay, there was typo. It is saying deleted, but it is hunged. Why? Because it is used, right? If I just take another session of this master node, I will show you. Let's quickly log in. And let's become sudo. Let me clear my screen. And now if you do that PVC, right? It is saying terminating. Why terminating? Because it is getting still used by this pod. The moment you delete this pod, right, automatically it gone and you will get your prompt back, right? So that is one thing. And if you see your PV, so PV is still bounded because it is bounded, right? Obviously. So let me delete the my pod, kubectl, delete pod, and give the pod name is pod PVC. Just keep your eye on the left hand side on this prompt, right? And I will gonna run this once it is done. It is gracefully, it is shutting down and then it will give you a prompt back. Come on. And what is happening on our master node? Okay, it was there. You can see that prompt came back, right? And if I do this, so it is saying that no PVC. And if you see your PV now, it is again retain and status is released. That means that it is not available now, right? You cannot do it again, right? Let me try to uh, first I will show you one thing, right? Let's say you, okay, now I will need to delete it, right? So what we'll do is I will just gonna create a pod called, okay, here we will create because we are already in the same directory. It is created now. Let's see. It is pending now. The status was released, but it is pending now. Let's see what is happening is kubectl logs. If I do the pod PVC, there is no log because there it is not started. Then how you gonna check what is happening to the pod, right? So for that we will describe our pod called pod PVC, and in the below line if you see that what it is saying is persistent volume local PVC not found. Obviously there is no PVC, right? But let me create that PV first and then I will show. First I will delete this. Delete pod local. No, what is the pod name? I again forgot. Pod name is pod PVC. Okay, it is deleted now. And let me clear my screen. Kubectl get pods. Right? Now let's create a PVC again. Kubectl create -f29. Okay, we need to go. Come on. Kubectl create -f29. Okay, PVC is created. Let's check the status of PV. You can see that. And you can check the status of PVC. It is pending. Why? Although we are using the same thing, right? But remember I mentioned when you say the policy is retain, that means that your PV will, when you delete your PVC, right? Your PV will stay, but it will not available for further use. So you can see that it is released now, but you cannot check that something, right? Do we have the data there? Let's quickly see. Yes, I have the data. Same thing, PVC test log, which was there, right? That is the reason we are doing this. Retain or maybe delete policy. That is one thing. There is one more thing. Let me quickly delete both. Delete PV, and the PV name is local PV, and let's delete PVC, and PVC name is this one, right? Now we don't have anything. If I quickly go 29, right? And I will change this to read write many. Fine. And I will create first PV. Let's see, kubectl get PV. Okay, it is still using the same thing, retain, right? Because that was creating a doing on the same thing, right? Let me quickly delete it and we'll change that behavior. Delete, because it is referring to the same directory, guys. That is the reason. PV, and the PV name is this one. Okay. Now let go to the 28, and I will say data 1. Fine. Now let's create PV, and now let's get name is same. Sorry, again we need to delete. Shit. Just give me 1 second. I am saying PV1. Persistent volume storage is fine, read write, and I'm doing that stuff. Fine. Now let try one more time to create. And now this time if I'll see PV, so it is saying that you have that local PV1 which is available now, right? And policy is this one. Earlier also it was there. I was referring to this, my bad. But you can see that now we have that local PV1 and it is available now, right? Because we have recreated that. So earlier it was also available because we have done. But now what I want to show you is here I am just doing the read write once, whereas in the 29 one I am just doing that read write many, right? But here we need to refer to that what? We need to refer to nothing. We need to refer to read write once. So now it is not matching this stuff, right? With the default behavior you can see. So let's see whether it will bind the that PV to this PVC or not. That's what I wanted to show you. It is created now. Let me clear my screen. And if I'll show you kubectl get PV and PVC. So here you can see that your PV is available, right? But your PVC is still pending. Why? Because it is not finding any PV which has a permission read, write, many, right? So whenever you are doing this kind of stuff, right? So you need to make sure that what is the access mode you are giving, what is the policy you are giving. So this is something and the size, right? Obviously the size also matters. If let's say your PV is 1 GB and you are requesting for 2 GB, obviously that also it will go to the pending, right? So these all things you need to keep in mind whenever you are dealing with the static binding, right? So that was the static storage in Kubernetes, right? So tomorrow we will see what is dynamic provisioning, and then we'll see the storage class, PV, PVC, and all this we will see in yesterday class. Sorry, tomorrow class. Okay. All right. So that was, I hope it helped you to understand like how storage works in the Kubernetes, right? So that is why I tried my best to explain what is PV, PVC, how you can get it done, what is the main thing you need to do, how the policy works, if it is retain, if it is delete, right? That's what you can check it. Let's check the this one quickly. Okay, let's say I am again changing it to once only, fine. And I'm creating a data one and 29 if I am going, and here I would say once. And if I'll quickly create it, kubectl create hyphen F29. It is existing because we need to delete it, or maybe or you need to reinforce it, right? That's what we have seen, that kubectl edit, and then it is giving the temp file, and that temp file you need to again apply it, right? But what we will do is I will quickly delete PVC called local hyphen PVC, and I will quickly create it. And now let's see what is the status of PV and PVC. It is again binded because it is also read write once, and it is also read write once, right? Now let me quickly delete it again. One thing I will just show you. Local PVC, okay. Cube kubectl delete PV local hyphen PV. PV1, okay, sorry. Okay, let's clear, and let's say in 29 number file I am just requesting this much of storage, right? Now kubectl create hyphen F28 kubectl get PV you have available. Okay, now kubectl create hyphen F29, right? And now if you get the PVC, you can say still it is pending because it is earlier access mode was not matching, then it went to pending. Now the size is not matching, obviously it will go pending, right? If you create that much of size in PV, right, automatically it got binded. That's how that PV PVC and with this no storage default behavior policy works. All right, so tomorrow we'll see the storage class and all this PV PVC and how it works. Again, if you find this useful to understand the Kubernetes storage, then don't forget to like, share and subscribe my channel for more CK content or maybe the other DevOps thing we will discuss. All right, guys. So that's it for the day, and I'll take a leave. Thank you. Bye bye.